Energy of an orbiting electron. Let us consider an electron of mass m is moving with velocity v in a circular orbit of radius r of a hydrogen atom. We know that the atom is stable. Then when the atom is stable, then the centripetal force is equal to the electric force. So our centripetal force is Fc, that is equal to electric force. So basically we know that our centripetal force is mv square over r and our electric force is 1 over 4 pi epsilon 0 e square over r square. So basically we will write mv square over r is equal to 1 over 4 pi epsilon 0 e square over r square. And the reason why we are writing e square because we have one electron and one proton in a hydrogen atom. Now if we simplify further, we will get mv square is equal to 1 over 4 pi epsilon 0 e square over r, because I am cancelling this r with this r square, and if I cancel, this r will be cancelled out and this r square will be r. Now let's simplify further, and if we do that, we will get the value of r, which is the radius, is equal to 1 over 4 pi epsilon 0 e square over mv square. And let this is our equation number 1. The kinetic energy of the moving electron is given as k is equal to 1 over 2 mv square. So we can substitute the value of mv square as 1 over 4 pi epsilon 0 e square over r for the kinetic energy, and if we do that, we will write k is equal to 1 over 2 inside the bracket 1 over 4 pi epsilon 0 e square over r. Now let's simplify further, and if we do that, we will get k is equal to 1 over 8 pi epsilon 0 e square over r, because 2 times 4 is 8, and that's what we have over here. And let this is the second equation, and the potential energy of the electron is given as U is equal to negative 1 over 4 pi epsilon 0 e square over r. And let this is our equation number 3. So the total energy E of the electron in the hydrogen atom is given as E is equal to K plus U, because we are adding the kinetic energy and the potential energy to get the total energy of the revolving electron. So if we do that, we will write E is equal to kinetic energy, which is 1 over 8 pi epsilon 0 E square over R, plus my potential energy is negative 1 over 4 pi epsilon 0 E square over R. Let's simplify further, and if we do that, we will multiply positive times negative is negative. So our expression will be E is equal to 1 over 8 pi epsilon 0 E square over R minus 1 over 4 pi epsilon 0 E square over R. If we simplify further, we will get E is equal to negative 1 over 8 pi epsilon 0 E square over R. And let this is our equation number 4. And this is how we will find the energy of an orbiting electron.